So hello everyone. As I promised last time, today we'll deal with arithmetics with integers, and by integers I mean changes or differences rather than counts. We introduced negative numbers because we needed to subtract larger numbers from smaller numbers. So rather than focusing on all types of additions, I'll only focus on additions that are problematic or subtractions that are problematic. So just to have a recap, what we mean by a negative number, let's say minus 2, it's not easy to understand minus 2 on its own, but we have to see, okay, if you add it to something, this can be anything. The meaning of minus 2 is that it is the same as if you are subtracting 2. That's how you will interpret negative numbers. So now let's do something. Let's say I have 7 here, and I subtract from this 3. Let me subtract from this 3. So what do I get? I know it is 7 minus 3. 7 minus 3 is 4. So you know that. So what if I subtract 3 plus 1? So I'm subtracting 3 and then I'm subtracting 1. So I'm subtracting more. Yeah. So in order to solve this, if you think about this, when this one was not there, I just had 7 minus 3 without this. But now I have to subtract 1 more. Yeah. So if I group this, and I'm doing this so that I can compare this without 1 and with 1. So this is the answer without this one, and when I include this one here, and then I have to subtract 1 more. So the number actually, this number has decreased because so this new number is now less than the previous number. Yeah. So the rule we learn is that if we are adding here, which means if we are subtracting larger and larger numbers, the answer or the difference, because you see, integers will be interpreted as differences. The difference will get smaller. But let me do something else. What if I replace this plus 1 with minus 1? Yeah. Compared to 3, I'm now subtracting less. So I should expect that difference should go up. Yeah. So I know this is 7 minus 2. Yeah. This is 2. 7 minus 2, you know, the answer is 5. And that 5 is in fact, when this one was not there, my answer would have been 7 minus 3 as before. But because I am subtracting less, now my difference goes up. Yeah, this minus. So now try to discover the rule. Yeah? What we learn from this is that subtracting a positive, if I now don't focus on this, if I only focus on this part, yeah, and then this part, yeah, I should say, actually I'm focusing on this part, yeah. So minus should be read as subtraction. Subtracting a positive number. Remember, I'm not focusing on 3. Yeah, I'm just focusing on this thing now. Subtracting a positive number will decrease the difference, yeah, without it, which means that negative of plus 1 is the same as minus 1. And subtracting negative is the same as positive. Yeah. So this these two examples gave us enough reason to discover this rule that minus, which means subtraction, of any negative number, and this should give me a positive change by that number. So if I now replace this by 2, subtracting minus 2 will be the same as adding 2. This is very important. Yeah? So we have discovered a new rule. So we will be needing this rule in the operations to come. So let's move on to multiplication. And in multiplication, I would now have only two columns, yeah? One for the conceptual world, one for the mathematical world, because here we don't need to talk about real world. I'll get back to real world, but not for this discussion. So if I have conceptual world here and mathematical world here, now we need to know what is meant by multiplication. So if I say, what do I mean by 2 times 3? Yeah. So before I write this down, this symbol, yeah, the cross, should mean 2 times. So I can say twice 3, 2 times 3 or twice 3. Now, if you have this concept in your mind, it should force you that you are basically adding 3 2 times 3. Yeah, and that you know is 6. So what is 3 times 2? Here you will have to say thrice 2, and this should be 2 plus 2 plus 2. Remember, you have to start from here. Some people say 2 times 3, yeah, is 2 plus, no, that is wrong. The standard is to go from here. So 3 times 2 is 3 times 2, 2 added 3 times. And you see the answer is the same. So what we discover, you discover that 2 times 3 and 3 times 2 is the same. It doesn't matter whether you multiply this first or multiply that first. I mean, this is pretty standard. I'm starting just to make you comfortable. The real challenge is now to give meaning when I have negative numbers. So let's start with that. So now, let's say I want to give meaning to 2 times minus 3. Yeah? If you remember, I told you what I mean by minus 3 alone when I don't have 2 times. Minus 3 is what? Let me write this down. Subtract 3. Yeah? So whenever this appears in some addition, you know, the meaning of negative numbers is with respect to how they behave in addition. So if this appears in some addition, or if you add this to something, yeah, minus 3 would mean subtract 3. Now, 2 times that will be, you do this thing twice. So you are subtracting 3 twice. Now, that's the advantage of conceptual world. You know that I have to subtract this 3, because minus 3 means subtract 3, and I have to do that twice. And if I do that twice, I know the answer is minus 6. And now, let me put this minus sign here. Now, this is really difficult if I try to have a mental picture of this. Conceptually, I mean, you cannot say minus 2 times 3. Here you can write it down, but conceptually, this is not a positive number. So, here we would like to do something interesting. Before this, if you remember, we discovered for positive numbers that it doesn't matter whether you write 2 times 3 or 3 times 2. The answer should be the same. This rule is so important, even if commutative, that we would like to have the same rule for negative numbers as well. So here we are stuck with meaning, but we can do something. This, according to this rule, we would like this rule to be valid for this, for every case, at least with numbers. So this should be the same as 3 times minus 2. And now I can think about a mental picture. 3 times minus 2. What is minus 2? Subtract 2. And what is 3 times? You do that thing 3 times. So I would say, so minus 2 times 3 is the same as 3 times minus 2, and that is thrice subtract 2. Subtract 2 thrice. And if you do that, I know, subtract 2, and then subtract 2, and then subtract 2 thrice. That is, again, you can work that out. So here we have now discovered a new thing. Very interesting. If I now combine these two results, I can say that in both cases I get minus 6. Whether I do minus 2 times 3, I'm using this bracket notation so that it is readable. Whether I have minus 2 times 3 or 2 times, so whether this minus sign is with this or with this, whichever, the answer is always minus 6. And now that 6 can be recognized as simply 2 times 3. So as if there was no negative sign, then 2 times 3, 2 times 3, so you don't lose that 2 times 3. So you see that in multiplication, this minus sign behaves in a very interesting way. This minus sign can be put outside, it can be put with one number or with the other number. So minus can float anywhere. That this is very important. We would like to have this rule in other cases as well, at least involving multiplication. So now I want to have some leap of imagination, and that is needed for the next case. If I now say, what do I mean by minus 2 times minus 3? Now this is really difficult because here I have minus, here I have minus. This conceptual model doesn't work here. So I want to use this property of the minus sign because I don't want to lose this property. This property should hold. Now this is very important. So I start from this and I do something. I start from this. Sorry. I just write this down. So 2 times 3. I have the minus sign and I know this is the result. Let me actually write this down. 2 times minus 3 because I don't want to corrupt that equation. Now let me do something. So this is the thing which I know, minus 6. And if I want to subtract this, that will be like negative of that. So what if I want to do negative of whatever I have? That would be like subtracting something. Why can I do that? In the first part of this video, I told you what should we mean by subtracting a negative number. Subtracting a negative number is the same as adding a positive number with the same magnitude. So subtracting this, I know, should be the same as. So let's come back to that later on. So here the property of negative is that it can appear outside, it can appear with one factor, it can appear with the other factor. Now this minus, I'm putting it outside, so this minus I can put it with this and I can put it with this, and it should not change. I require this as a property because otherwise mathematics will not be interesting. Now, so you have discovered something. Minus 2 times minus 3. minus 2 times minus 3 is the same thing, is the same as the negative of minus 6. Now you learned just a while ago that subtracting a negative number is the same as adding the positive number. So this must equal 2 times 3. Subtracting negative is the same as, so now I can have a mental picture. Subtract negative is the same as add the positive. So now I have discovered a new rule. Yeah? So when I multiply two negative numbers, even if it is very difficult to conceptualize, the rules of arithmetic dictate the answer. So whenever someone tells you next time that negative times negative is positive, there is no conceptual explanation. The explanation is dictated by rules of algebra, because you don't want to lose those rules. Without those rules, mathematics will cease to be powerful. So this was easy. Let me give you some preview of the next lecture that will be very important, because so far we are doing addition, subtraction, multiplication with pure numbers. But remember in the first video I started with quantities. Yeah. So next time we'll tackle the more difficult problem that will be more challenging. Is what if I have apple with this, like 2 apples times 3 apples, or 2 apples times minus 3 apples. Now that will not be so easy. This was easy because we were only dealing with pure numbers. So wait for the next video to tackle that more challenging mind-bending problem.